In this video, we will be building a chat app in 5 different frameworks. Take a look at 2 that we compare here side by side. We can send messages from one. We can even send messages from the other. And we'll have plenty more of functionality added to these applications. Can you guess which is the framework on the left and which is the framework on the right? I hope not, because they look very similar, and this is what we're trying to achieve in this video. Have fun! Well, welcome to another video on the Stream YouTube channel. Today we are going to build a chat app using not 1, not 2, not 3, not 4, but 5 different frameworks. These are going to be React, Angular, Vue, Svelte or Svelte Kit, and Next.js. As a backend framework, we will use Stream Chat, and we will share a project, so we will be able to chat between each of the apps interchangeably. We will see how to build up not only the functionality, but also the UI for all the different frameworks, which is going to be a lot of fun. Shh! For the last framework, that is Next.js, we will actually even add a bonus implementation here, so stay tuned till the end to see this. If you want to play around with the project, we'll also share a link to the Github Repo where you can download this and just play around with it yourself. So without further ado, let's get started by creating a project, and then we start with the implementation of the first app. But before we start, please like the video and subscribe to the channel. This helps us immensely, so we would highly appreciate if you consider doing that. Let's go! Before we start, let's quickly mention what we won't build. We won't cover building an explicit backend for things like user handling, storage of user accounts and more, but most of that will be handled by the Stream backend anyways. And for development purposes, we offer you a handful of tools that you can use during development to speed up that process. So let's jump right in. You can see the Stream dashboard here, and what we first do is we create a new application at the top here. We name it 5 frameworks. We need to set a location for the feeds API as well as the chat data storage location. I'm based in the EU, so let's select this. This cannot be changed afterwards, so it's important to set this to a region where the majority of your user base will be. We don't want to clone an existing app. The development environment is fine, so we can create this app. Once that's done, you can see it's not the most popular app at the moment, but I hope we'll get there. And we can see all kinds of data here, what we want to have as additional settings. We can have things like webhooks, but we won't cover that here. What's interesting to us is going to be the options we have here. And specifically, we have the Explorer here. This is where our data lives. And if we have channels and users, we see them here. It automatically generated a user for myself, as I was the creator of this app. But of course, if we want to test out the app, that's not really sufficient for us. So what we can do, we can populate this with some sample data. And yes, I could do this manually, but what I actually want to do is I want to populate this using a tool we have in our Stream suite, and I'll add a link to this in the description of the video, but basically it clearly states do not use this for production apps. So please follow this. And we will put the API key, the API secret, and the user ID in here. So let's collect this. We have the API key here. I can copy this. I can paste this here. The API secret. We can copy this and paste it here. And finally, we need the user ID, which I can set as my development user ID. So we have a token, which is not going to be that relevant. But first, we want to generate the random data. So let's generate this. There will be more users added. There will be some channels added and more. Again, this is just for development purposes. So if we now go to the Explorer here and go to channels, we see we have a bunch of channels created. We have some users added with some names. So this is exactly what we want to demonstrate how to build the applications themselves. We need one more thing for building up our apps, which is gonna be a user token. So whenever a user logs into an application, they need a valid JWT, which would normally be assigned from the backend that we create. Since we want to skip this for the purpose of this video, we can also just generate these using another tool that we offer, which is also just for development purposes. And this is this tool here, where you can put in your secret and a user ID, and it will generate a user token for us. So let's do this for an example user. This is the ID of the user. I can put this in, and I can put in the secret of the application, which is what you would need if you do it in the backend. And as you can see, we have a JWT that is generated that does not expire. So again, it's just for development purposes, but it really helps the ease of the development process for the apps that we are creating. So with that, we have all the necessary data to build up the applications, and we will start off with a React application. So let's go. We're starting off with React as a framework, and as a lucky coincidence, there is a Stream SDK that is tailored specifically towards building up a chat app with that. So we're going to use this, but if you're now saying, oh, well, that's cheating, then you're right, it is. But in the later frameworks that we're using, we will also build up everything from scratch because we don't have SDKs available for everything. So transferring this back to a framework like React will be rather simple. So the concepts we will show later on, but we would be stupid if we wouldn't use the framework that we have at our hands. So let's get started. I have my terminal open, and first I will use the create React app command to create a new application, and I'll call it React Chat App. This is now created. It will take a while, so I can speed this process up by doing just this. And with that, the project is set up. Before we start the project, we first switch into the folder here. And now we want to install the necessary dependencies. And specifically, these are two. So let's clear this. And now we want to use npm to install both the Stream Chat as well as the Stream Chat React SDK. As I've mentioned, we are making use of having an SDK available, and the advantage that we get from this is that a lot of the UI components that we need are already provided for us. We can customize them, which we won't in this video, but we have plenty of other content around that. So we won't cover this here, but we get a lot of the UI components for free. And again, I'll show you how to create these by hand later on. But for now, let's open up the project in VS Code. The project is set up. We can scroll through. It's a very basic React project, but the last thing we want to do for now is to get it running. So we use npm run start. This seems to have worked. So if we now switch back to the browser and go to localhost on the port 3000, we can see this works. We have the skeleton ready, so we can jump right back into the code. So we can open up the app.js file, we can close the sidebar. And this will be the place where we do all the implementation. But of course, we don't want the boilerplate here. So let's select everything and get rid of it. With the blank slate that we have now, we can start filling this up with content. First, we'll add a bunch of imports that we'll get to later on. Next, we import the app.css because we want to add some styling to our application. And then we start by defining the API key. As a reminder, you can get this from the Stream dashboard. If you're unsure how to do this, just jump to an earlier point in the video where we do just that. Aside from the API key, we also need some other things to initialize a chat client. Specifically, we need a user ID, which we took from a user in the dashboard. So we have the users here. There's a user, and this is the user ID that we just copy. They also have a name, which we will add next. And then we need a token. Just as a reminder, we can get this token using the JWT generator. So we can insert our secret and we can insert the user ID, and with that we will get a token generated for development purposes. This is the place where we would usually insert something like a generator or a backend that will generate the token for us. All right, we have all the credentials that we need. So let's add a user object here where we put in the user ID, a name, and even an image URL. This is just a URL that will give you a random image from the Stream dashboard. And then we start by defining our function, the function app, which we export as the default so that we at least get something in the end. And now we'll fill this app up, which is going to be the central component that our app returns. So as the first step, we want to initialize the client for Stream Chat. So we will do that. Luckily, there is a use create chat client hook from the Stream SDK that we can use for this. And we simply need to import the API key. We need to add a token or a provider. The advantage of having a provider is that once a token expires, we will automatically call the provider again to issue a new token, if that makes sense. And lastly, we need to input some user data, which is the object we just defined. Now with that, we have the client being initialized, but this can take a while. So we will say if the client is not fully initialized, we return a loading state. If this is not the case, so if we know that our client is fully initialized, we can now start building up the UI. Usually we would need to do this by hand, but since we have an SDK available, we will use the pre-built components. And again, I will show you later on how you can customize this to be your own components, which will be necessary for Vue and Svelte. But for now, we can use the existing ones. So let's start by adding a chat object, which is the root, where we put in the client. This will inject all the necessary data, specifically access to the client and other properties in the child elements of the chat element itself. With this, we would already initialize the chat correctly, but now, of course, we also want to show something. So the first thing we're going to show is a channel list. And for this, we need to determine which channels we actually want to show. For that, we need a few more properties. Specifically, we start off by a sort property, which simply says we want to sort all messages in each channel by last message first. So then we have the filters object, where we can now say we want to filter only specific channels. And we have two properties here. The first one is that the channel should be of type messaging. We also have other channel types, which you can find documentation for in our docs. And I will add a link to that. but the usual one for chat is messaging. And then we also want to have only the channels where our current user that is logged in is member of. That makes sense because otherwise we would get an error since the user would try to access channels they're not a member of. At least if the user is a standard user, admins can have other access rights, so that makes sense that we only see the channels for the specific user. And lastly, we have options. For example, we can limit the channels to 10 to be more efficient, and we can set this to a random number or omit this to load all the channels that the user is a member of. Now with these properties, we can now initialize the channel list by adding the sort, filters, and options objects here. And since we have a channel list, we also want to have the content of a specific channel, of course. So with this, we have a channel object that we can now fill up with the necessary components that we like. Specifically, we would just add a window, and for that we have a channel header at the top, which should show the information about the channel, the message list, so all the messages that the channel consists of, and lastly we need some message input to be able to send images. The last thing we add is a thread, so if we have a threaded conversation, we can also display this in a nice way. With that, we have all the necessary UI already implemented with these few lines of code, since we can use the pre-built components in a very nice way. Next, let's take a look at how our React chat app looks. For this, we're switching back to the browser and are taking a look here. And as we can see, that does look terrible. We see that some of the components are already there, and we see that these could be the channels, and here we have messages, but clearly it doesn't look great. So we need to add something to the styling. For that, we switch back to VS Code, and here we open up the app.css file, and first of all get rid of everything here. That helps to clean things up. And now we need to import the CSS that's specific for the Stream SDK. We can do this inside of our CSS file by first saying we define a base layer, and then we import the index CSS file from the Stream Chat React repo. This will already improve things, but we can go further and define some more properties. Specifically, want to give a 100% height to the HTML, the body, and the root element, remove the margin, and set the display flex on the root. And then we can also define some dimensions. Specifically, we can override certain variables from the Stream Chat SDK. Here, we override the channel list class with a width of 30%. And the channel to be the width of 100%, and a thread should be a width of 45%. If we save here and we open up the browser again, we see that now, once we reload, we see the UI looks great now. We have all the functionality. We can switch between channels. We even see the unread indicators disappearing here. We have an unread messages thing that we can click and it scrolls up. We have message reactions here that we can do. We can do threads. We can even reply to certain messages and get a lot of functionality for free thanks to the SDK. And we can also write messages, and we can write hello from the React app and send this, and the message will appear. We see that it's delivered, date, and everything. So by using something like the pre-built React SDK, we get a ton of functionality for free, which we won't implement for all of the apps because this is a lot of work to get everything right. But at least we're getting this if we are using an SDK. So this is how we can build up a chat app using React. As you can see, it's only a few lines of code really. But also we're cheating a little bit since we're using some pre-built UI components. But since we like cheating, let's jump to the next SDK, which is going to be Angular. I already said that we like cheating, so again, for Angular, there is an SDK available from Stream. So we'll go over this rather quickly again, because we will leverage all the UI components that we get from the Angular SDK. Notice that I've changed the coloring here so that we know that we're using a different framework. I hope I have enough colors for all the frameworks. Let's see. The only prerequisite we have is that we need the Angular CLI to be installed on the machine. With that being done, we can jump into our terminal and start off by writing ng, which is short for Angular command in the Angular CLI. And we type new Angular chat app. We set routing to false. The style should be SCSS, and we set server-side rendering to false. This will create a app with everything that comes packaged with the Angular project. And once this is finished, we can now change into the directory and bring this up here. And now we can install Stream Chat Angular, Stream Chat, and the NGX Translate core package. Again, this will take a few seconds to finish. And we can now open up the project in VS Code. Once that has loaded, we can jump into the terminal here and run npm run start, which will use the ngserve command to start the app on localhost 4200. So if we go to localhost 4200, we can see the Angular chat app is working. So our project setup worked, and we can now jump into the implementation. For this, we jump back into VS Code and first open up the app.config.ts file located in the source app. So first we add an import for import providers from the Angular core package, and then we import the translate module from the NGX translate core package. And then we just add this to the providers here. So we use the import providers from function to initialize the translate module for root. With this, we can save this, and we need to do one more setup step inside tsconfig. And here we simply want to say we want to allow synthetic default imports to be true. With that, we can close these two files and open up our app component.ts file and initialize stream chat here. First, we need to import a few modules here. Specifically, we want to have the translate module as well as the stream autocomplete text area module and the stream chat module. We need to import these into the component, first the translate and then the two stream modules. Now, we need to initialize the stream client with credentials. So let's define these similar as we've been doing this in the React app. First, we want the API key, the user ID. We select a different one here compared to the React app. If you're unsure how this process looked, then jump back to the React app. I won't repeat this here. We need a username and a user token. I generated this using the tool that I showed earlier. But in a regular app, you would want to generate this in a backend service and issue this token whenever a user logs in. Now, the next thing is we need a constructor where we can actually initialize the stream client. For this, we need to add some imports. We need to add the chat client service as well as the stream internationalization service. That's the reason it's called i18n. And in the constructor, we put the chat service and the stream i18n service. And for this, we need to define a user with the ID that we defined, with a name that we defined, and we again set a image with the username. This will give them a nice default image. And then we can initialize the chat service using these credentials together with the API key and the user token. And we also need to initialize the i18n service and set the translation. While we have stream chat initialized now, what we are not doing yet is loading any channels or messages. So let's do this next. For this, we want to say on init. So whenever the lifecycle initializes the component, we want to load the channels and with that all the necessary messages. For this, we need to again add some imports. We need to have the channel service available now. This is a out-of-the-box tool that comes with the Stream Angular SDK. And we need to add this to the constructor here to be initialized. And then on init, we can say we want to initialize this channel service. We want to have all channels of type messaging. And again, we need to filter here for only channels that the current user that we're logging in is a member of. With that, we can save. And when we switch back to the browser, we see beautifully that nothing has changed because we haven't touched our HTML code yet. So this is still showing the default. So let's change this. We go to appcomponent.html and we see there's a lot of code here. And we'll do the most satisfying thing of taking all these 336 lines of code and deleting them. That feels good, right? We can start filling this up with first a div that is our root element here. And then similar to the React SDK, we can use the pre-built components to populate our window here with the necessary chat components here. So let's do this step by step. So we first add the channel list because we want to show a list of all the channels. And then inside each channel, we want to have a channel header. We want to have a message list. So the list of all the messages that the channel consists of. And then a notification list to visualize notifications that come in. And finally, the message input that allows users to type messages. But this is not the last thing. Same as for the React SDK, we also want to display threads inside of the chat. So we add the stream thread component. And here we again have a message list and a message input with the mode set to thread. So it has two different modes. Above we're using the main mode and here we're using the thread mode. This is actually all the HTML that we need for this to work. So if we take a look at the browser, it looks beautiful, right? Not quite, but we had the same issue with the React app. So I think we know how we can fix this because for now we haven't done anything with styling. So what we can now do is we can open up the styles.scss and populate this with our styling code. We've already explained this for the React SDK, and for the Angular SDK it's the same, that we first need to import a styles file from the Stream SDK because this will do a lot of the styling for us already. Then we can set a few more parameters. We want the HTML to be the height of 100%. We give the body the same height and 0 margin. And then for our root element, which we defined inside the app component HTML, we add some styling, display flex, and again, a height of 100%. And then we do the same thing as we've done for the React SDK. We set the stream channel list to a width of 30%. The channel should be 100 and the stream thread should be a width of 45%. We save this. And last thing I want to mention here is that, of course, this is not perfect yet. It would require us to do some more responsive design to make sure that it looks good on mobile and everywhere. So just keep that in mind. But for now, let's take a look at how this looks in the end. And we can already see this looks way better than before. All the styling is there. We have images, we have the messages from the user as well as other users here. We have message reactions. We can add reactions to this. We can add responses. We can do a thread reply, a quote reply, something like this was a fun message. Send this and we see this in line. So we have all the functionality that we get for a fully functional chat app right out of the bat with all this that we have. With this, we finished the Angular implementation, but I want to show you one more thing just to demonstrate how powerful the thing we've already built is, because we have our Angular app running here, but I've started the React app that we built in the previous chapter, and I want to demonstrate that we can now chat between the frameworks. So I'll add a split view here and add our React application here. And as we can see, the different users are in the same channel here called Jazz. And now if I write a message here, we can already see there's a typing indicator and we send a message, it appears directly, and we can now chat between different frameworks in a very easy way. So we not only have built a React and an Angular chat app, but we've also built one that works together using the same backend. Now this already marks the end of the easy part because we have used the SDKs that Stream offers for React and Angular. And now we will go to two other frameworks who do not have an SDK available. For the UI at least, we can still access the low-level client, which we will need, but we'll build out the UI completely ourselves. So let's jump into the next framework now. The third framework we're using is going to be Vue.js. For this one, we're venturing away from having a UI library available to us, but instead we will build it all ourselves. This works because Stream offers a low-level client that we can use as a standalone package and build up the rest ourselves. This means that we will not build all the functionality into the application that we have seen from the two previous frameworks because it just would take too much time. We will build up the basic building blocks for a chat application to have that functionality fully supported. So without further ado, let's get started. We jump into the terminal to set up a new Vue project. We can do this by using npm create Vue latest. We'll go through the setup here and let's call this Vue chat app. We want to use TypeScript. Yes, we want to omit JSX support. We don't want to add the Vue router. We want to use Pinia for state management. No unit testing, no end-to-end testing solution. ESLint and Pinia, we want that, but we don't need additional tools. So we can now cd into the project. And let's make this a little bit more obvious here. We can now install the Stream chat package, which I mentioned is the low-level client. So we will notably not install any UI components here. So we have to build them up ourselves, which is going to be fun. This is going to be more work than for the previous projects. But first things first. We have the package installed now. We can now run the format command. So we will format everything. And then we can do npm install and npm run dev. And now we have this exposed on the local host. So let's jump to the browser, go to localhost 5173. And we see we have successfully set up the Vue project. So everything worked here. And the next step is to open up VS Code. So let's switch back to the terminal and open up VS Code in this folder. We make it a little bit bigger and we are ready to go. The first thing is that we can get rid of a few of the files here. Specifically, we have a components folder, which we don't need. So let's delete this. We have a stores folder with a counter. That is just the demo how to use Pinia. We won't need this as well, but we will create our own store. And then we have the app view file that, again, we will also completely delete, which is not where we start. But instead we will first create a store to implement the logic we need. And from then on start with the implementation of the UI. So we save this empty file. And the first thing we create is a .env file to have the two variables here, which the first is going to be the API key. And the second is going to be the JWT. So our authentication token. I'm adding the API key here as well as the token, which I already generated. And I'm saving this. All right, with this ready, we can now create a new store file. Remember, I said that I want to create the logic first, and then we will continue with the UI. We call this stream store.ts, and we close off the sidebar. Before we start, let's quickly mention again what the store object actually does. It is a mechanism which is using a framework called Pinia, which is the recommended solution for state management in Vue.js. It is really powerful and you can easily inject a store into the whole application, which you can access everywhere. And it makes it really easy. And I'll add links to the documentation for Pinia and how to create stores in the description of the video, but we will see how this works while going through it as well. First, we need to import a few things, the ref from Vue, then from Pinia we need to use the define store to actually set up our store, and we need a few properties from the stream chat client. Then we can start with the define store function that we imported from Pinia to actually create a store and give it a name. We can later access this using the use stream store function. And now inside we can first define a few variables that we can then access from outside. So first we will have a channel keys property. And this is a dictionary which has a key, which is a string, which is going to be the channel ID. And then as the value, it has a channel object. We will initialize this as an empty object, but we'll soon do the loading part. Then we're going to track the active channel. So we want to display one channel as the currently active one. And this is going to be how we track this. Then we will import the API key from the environment file that we just created. And doing the same for the token. We will check if these are actually there. If not, we're going to throw an error. Same for the token. And then we can start by initializing the client. We're using the streamchat.getInstance using the API key that we imported from the environment file. Finally, we define the user ID of the user we want to initialize. Hard coding this is not very common in a production application, but for our use case, it's fine to do this. Otherwise, we would need to grab this from some input form for the user. Now we have the active channel, but we need to set this somehow. So let's add a setter function, which is simply assigning the value or setting it to undefined for the active channel. Because this is a ref, so a reference in Vue terms, we can only access the value for this and set this. While we have initialized the stream chat client, we still haven't initialized our user yet. So we add a function to do this. And with this function, we have everything necessary that we want to expose in our UI component later on. So let's already export this. And what we do here is we return an object, and these are all the properties that we expose when we import this inside of app.vue. Then we continue with the implementation for setup user, and we want to do two things here. The first is that we want to connect the user that we have just defined. And the second is that we want to load all the channels that the user is a part of. So let's do this one by one, starting off with the connect user function. Here we define the user name, which is Rogelio. I hope I pronounced this correct. And then we define a user object where we put in the user ID that we defined up here. We put in the username and give them an image using the username here. Then we can call the client.connectUser function using the user as well as the token that we have in our environment variable. Again, in a production app, this should be created dynamically. And then we want to have the load channels function. So our user is now connected and now we can load all the channels that they are a part of. First, we set up a console log for displaying that the stream store setup is actually done. And now we can create a filter because we only want channels of the type messaging, as well as only channels that the user with the user ID is a member of. We can also add some options. Specifically, we want to limit the channels to 10, so no more than this, to be efficient at loading. And we want to set this watch parameter to true. I will get to what this means in a second, but let's continue first, because now we can actually query the channels using the client that we've defined with the .queryChannels function. We need to put in the filters. We need to sort this somehow. For us, we do it as the last message last. And then we have the options object that we just defined. Now we can say if the length of the query channels array is bigger than 0, we can set the active channel.value to the first element here. Again, the active channel is what we've defined here to display on the second column of our UI. And then for each of the channels in the query channel, we assign this inside of our channel keys dictionary. So we need to access the value of this, take the channel ID as the key, and then we can assign the channel as the value. Now remember when I said that we need to have this watch property set to true. And what this does is it says, please notify us whenever there are changes in the channels that we have just queried for. So when there's new messages, when there's new users arriving to the channel, there's a long list of events that can happen. And I'll also add a link in the description what events are possible. But what we need to do is we need to react to these events if we're interested in them. For this, we can use the client.on function. And here we are listening specifically to the message.new event. So whenever a new message appears, we want to first have the channel ID for this channel where the message appeared. We can do this with the event.cid. The CID stands for channel ID. And if this channel ID is actually there, we can extract the channel from our channel keys.value property. We can extract the channel messages. We can say if both are there, we want to set the channel keys.value of this channel ID and the state.messages here to the channel messages. This is all the logic that we need, but I think the slightly bigger challenge is going to be implementing a whole UI for a chat application. So let's save this and let's close this. And now let's start with the implementation of our app.view component. Before we do that, I want to quickly mention that we will cramp everything into one file for the purpose of this tutorial. We should branch it out into separate components, but to keep it simple, we just create one massive file and that's it. So let's get started. First, we need to have a script tag. We want to have some logic involved. And by setting the setup property here in the language to TypeScript, we can make sure it runs whenever the component, so our app.view file, gets mounted into the system. Then we import the stream store that we just created and initialize this. Then we want to have access to the refs from the stream store. And for that, we need to import the store to refs property from Pinia. And with that, we can include the store here, and from that extract the channel keys as well as the active channel that we will need in a second. From this we can call the store.setUpUser function that we just defined, which will not only log in the user and initialize it, but it also will load the channels, therefore populating the channel keys as well as the active channel if there is one. This is all the setup code we need for now. So next, let's create a template, which is the HTML portion of a Vue file. We put in a main element, and for that we want to add some styling already. So let's also add a style tag and make it scoped to this specific component. Now for the main element, we add the styling of a grid element. We want to make it spread the full width and height and give it a 2-column layout. So the first column, which is going to be the list of channels, will be 240 pixels, and the rest will be occupied by the currently selected channel. We give it a slight border, and that is it. Next, we will fill up the HTML further, and we start by adding a section for the channel list. Let's first add the necessary HTML, and then we will add the styling that we need. We add a button because we want to be able to react to a click on each of the channel elements so that we set this to be the active channel. In this button, we give it another class. We say if the active channel is this currently selected channel, then we want to give it the class of active channel preview as well. We will add a little background color for this so that people know which the active channel is. And you can do this with the :class property in Vue. Then we say for each of the channel keys, so we say the channel, which is the value, and the key, which is the channel ID. We can access this and make this the key of this property. We need to identify it uniquely because we have a list of properties and the SDK needs to know that each of them is a unique element. And then we say on click. So whenever we click on this button, we want to call the setActiveChannel function of the store to the current channel. Now let's fill this up. First we add an image, which is going to be the image of the channel. And then we add another div here with a headline, which is the channel name. And if we don't have a name, we fall back to the channel ID. And then we want the unread batch here. So if there are unread messages, which is this check here, we count the unread messages. And if this is larger than 0, we want to display this, and we add the styling later on. And then we want to have a paragraph which says, give me the last message text. So we take the channel, we get the messages, we select the last message in the channel and display the text for it. This is all the HTML we need for the channel previews. So let's add the styling now. So for the channel list property, we simply give it a border on the right side to separate out the channel list from the message list that we will implement in a second. Then for the channel preview, so the item that actually shows the contents of the channel in the preview, we set this to be display flex, width of 100%. We align all the text to the start, give it a white background, add some slide padding as well as a border, and set the cursor to be pointed to indicate that this is clickable. This is not fully responsive, but for the purpose of this tutorial, it should be sufficient. Then you want to give the headline in the channel preview some more styling to be display flex and align everything nicely and give it the space between so that the unread indicator is going to be spread out all to the right and the title or the name of the channel is going to be on the left. This unread batch then will have a background of red. We make it round, give it some slide padding, fixed width and height. We set it to display flex and center it horizontally and vertically and give the text the color of white and a font size of small. And then the div inside of the channel preview should also have a white space of no wrap. It should clip the overflow to the on the x-axis, and the overflow on the y-axis should be hidden. What this code does is it will clip the last message here and add 3 dots to the end of this to basically indicate that there's going to be more content on the message, but it won't show the full message. And then for the images, so we have the channel preview here, and we also add one for the channel header here. That's going to be later on. We add a fixed width, an aspect ratio of 1, and a border radius of 50%, as well as a slight margin. The H2 will get more styling with a font size and a 0 margin. And then for the paragraph inside of the channel preview, we set a font size, we set the color to gray, and do the same thing for the styling of the width and showing the ellipses whenever the text overflows. Finally, for the active channel, so whenever we know that this channel that we're currently looking at is actively selected, we set the background to a different color to make sure it is distinct from the white background of the regular channel previews. If we hover this, we want to give it another background, which is going to be slightly lighter, but we will see this in a second. With this, the channel list is done. We can even save this. We can even take a look at how this looks in the browser, and we see this is how we want it to look. We have one channel here only, but if we hover over it, the color changes. We can click on it. We won't show anything here, but also we see the borders here being applied. We see that there is actually a left border here, which we will get rid of in a second. But aside from that, I think the preview looked quite nice. We have the title, the unread badge, and the image here. The last message is clipped here, so everything looks very nice. So let's first get rid of this, which is going to be important for us to do. So I think we need to go to the main.css file here, and we see the padding on the app here is applied. We need to get rid of this, and we need to get rid of it here as well. And if we save now, we see this border is gone. So with that, we can continue the implementation in our app.vue file. With the list of channels done, we can now build up the channel view itself, which is going to be 3 parts. The first one is going to be the header. The second one is going to be the message list. And the third one is going to be the composer, so where we type in a new message and send this. So let's start off with the rough HTML here. We have a new section, which is going to be the channel section, which is only active if we have an active channel. If this is not the case, we simply display the text, no channel is selected. We should never see this because we always have channels in our case. But if you want to have a more distinct message for this, you can also customize this, of course. Then we directly add some styling here. So let's say if for our channel section, we give it a display flex in the flex direction column and make it a max height of 100 dvh. If you're not sure what the D stands for, that's the device height. So check MDN if you want to know more about this sizing. With this, we can add the first element here, which is going to be the channel header, which has an image, which is going to be present if there is actually an image for the channel. The source is going to be that specific image, and the alt text is going to be channel image. And then we have a div here where we have the active channel name again, which is quite similar to the preview one. We have a p element, which is going to say we have this many members accessing the data of the current channel for the member count, and the watcher count, which is going to be an indicator of how many people are currently online in this channel. Now to style this, we will add a new channel header class to the style properties, giving it the display flex, aligning the items in the center, giving it a slight margin on the bottom, and a padding. The paragraph on the channel header is going to get some specific font size, a little bit smaller, and a color. And we already added the HTML for the image in the channel header to be similar to the one in the preview. With this, the channel header is done, so we can now add the message list. The message list will also have a div which is going to be the message container. And here we say for each message in the active channel's messages, which are found in the state of the active channel, we want to say the key is the message ID. So we have a unique property here. And we now want to distinguish between messages that are from the user themselves or from other users. For this, we need a little helper function, which we add to the script tag. So first we import the message type from stream chat. And then we add a function called isOwnMessage, where we can put in a message and it will indicate to us whether this is a message that the current user has sent or someone else. And we simply do this by checking if the message.user.id is the same as the user ID inside of our store. Now we can use this to also add the class of ownMessageContainer if this message is in fact from the current user. We will add the CSS for this in a second, so let's stay tuned for this. Then we add a message class, which again checks whether we have a message that is from the current user. If this is the case, we set a class of ownMessage, and then we add a div inside for the attachments. So there can be multiple attachments such as images, files, and more. We only cover images here because it's a nice visual effect that we will see. So we say if the attachments.length property is there, and if it's larger than 0, we want to give it the class of message image container, and even give it another class of multiple images if the length is larger than 1. And then we add this image tag here, and for that we first need to extract the images from the attachments. So let's import the attachments as a type here, and then we add another function called image URL for message. And for this we take the message, we take all the attachments from the current message, we filter them for only the attachments of the type image and return them. So this is going to be an array. If we don't find any, we'll return an empty array. Otherwise we have now the image attachments, which we can then use inside of this image tag here. So we basically say for all the images in the image attachments, we want to give them the key and the source here of the thumb URL, which is going to be the image URL, and display them. And then we have the message text, which is going to be a simple P element that we will style right now. So let's add this as styling to our style elements. We have the message list first, which is going to be flex 1. So it will take one portion of the screen. We have the overflow Y of scroll because we want to be able to scroll the message list and give it a slight padding. The message container will also have a display flex in a column direction, some margin, and in the Y direction also have a scrolling effect. It will also have the max height of 100%. And then for the ownMessage container, we simply set the align items property to be end. So the own messages are going to be aligned towards the end, whereas the messages from other users will be aligned to the start. For the message itself, we give it a max width and a background of a slight gray. We hide all the overflow and we give it a border radius of 1 rem, 1 rem, 1 rem, and 0, which will leave the bottom left of it as no radius, and the rest is going to be rounded. Then for the P element of the message, we also set a padding. And then for our own message, we do a different kind of border radius because here we want to set the bottom right to be not rounded. We also give it a slightly different background. And then for the images, we first have the image container, which has a grid display, but we only want to have one column here. We give a slight gap. The padding is going to be 2 pixels. The overflow is hidden and the height is 300 pixels. If we have multiple images, we only need to change the template columns to be 50 and 50%, only being slightly different from this, and the rest will stay the same. For the images themselves, they should be covering the whole width and height, and they should have the cover object fit, and a slight border radius as well. With this, we have all the message list already. So let's save this again, jump back to our browser here, and we can already see this looks quite nice. It's all moved to the left because we don't have our own messages here, it looks like. But the styling looks nice. We have this edge here at the bottom left, as we suspected. We have the roundedness here. We have multiple images which are shown quite nicely. If there's a single image, this is also shown in a nice way. And we can scroll up and down for the messages. So everything looks just as we expected it and just as we have seen from the React and the Angular examples. So I think we're getting somewhere. One thing that's missing though is the current date or time of the message. So when the message was sent. So let's quickly add this. We call this message signature. If this is not our own message, we want to set the user name. And as I said, we want to set the time or the date. And this can be either of type date or type string. If it's a string, we format this as a date and then return the date to the local date string. And then we can display this using the format date function that we just defined. For the message signature, we also add some CSS, which is going to be display flex, a slight gap, a small font size, and a color. We save this and jump back, and we now see that this has the name of the user and the date. Here, there's a different name and a other date, and we have all the naming correctly here. Nice. So the only thing remaining is going to be us sending our own messages, which we will add to the bottom here next. We switch back to VS Code and add the message composer next. So we add a new div, give it the class of message composer. And to make this work, we need a new variable, which we call message, which is going to be a ref. So it's going to be a dynamic variable that we can change because we need this to track the input. And once the user hits the send button, we will actually send this message and reset it to be empty again. So let's scroll all the way up and let's import the ref from Vue. And let's say we have a const message, which is going to be an empty string for now, but we'll fill this now. Then we scroll down to the message composer and we add an input element, which we say we want to bind the message as the model here. We give it the type of text and the placeholder of type your message. We add a button to be sending this away. And we say we give it the active icon class if the message has a length of bigger than 1. Now, of course, when we hit the send button, we actually need to do something. So let's add a function for this. We call this send message. And we say if the message.value length is larger than 0, so if we have a string that's not empty, we want to say the active channel, if we have one, we want to call the send message function on this with the text of the message.value and then reset the message.value to be an empty string again. With that, we can add this as the click function to the button that we just created. And now we still need to have text or an image for the button. And I went with an image here, which I got from a beautiful site called Hero Icons, which is by the makers of Tailwind CSS. And they have this nice little paper airplane that kind of looks like the image we use for the Stream SDK. So let's add this here. I copied the SVG and we can use this here. Now we need to add some styling to our composer. For this, we scroll all the way down and we add the message composer class. Give it a display flex, a gap and a padding and set it to the full width. And then the input type text inside of our message composer, we add a flex, we add some padding, a border radius and a border. And for the message composer button, we give it no background, no border, and we set this to be the cursor of pointer to indicate that it's clickable. And finally, for the SVG, we set a new CSS variable, which is called icon color to be gray. Set this as the color here, give it a width and an aspect ratio of 1. And then we say if the icon is active, we want to change this icon color to be the blue color of stream, so our brand color. And if we change the CSS variable here, the color of the text, or the SVG in our case, will change as well. We save, and now we can take a look at the final result. So we switch back to our app. We now see the composer here. We can scroll only the messages, which is exactly what we wanted. And we can even type in our own message now. So we click inside of the composer, we see the send button here. And once we start typing, it should turn blue. We say this is a test message, it works. We see this as blue. We can now click it. The message is sent and we need to scroll down. Again, something that the SDK automatically provides us with, this automatic scrolling behavior. But we see this message was sent. We see this message is from the current user because it's right aligned here. And we see the date being attached to this, no name, but the date. And we see the different background color as well. So our code works just as intended. With this, we have built a fully functional application using Vue. And we have seen that we needed to do a lot more things manually because we don't have a UI SDK for this. But we were still able to achieve this in a reasonable time with access to the low-level client that Stream offers and some HTML and CSS code that helped us achieve this nice looking effect. Now let's jump to the next SDK, shall we? The next framework we're going to work with is called Svelte, or Svelte Kit specifically, which is the static site generation tool that is mainly used nowadays. Now, Svelte is a tool that scores very high in the satisfaction of developers using it. So we thought it might make sense to include it in the list. For this one, we need to again build up all the UI ourselves because there's no SDK for UI elements available. But we will do the similar approach as for Vue and start off with the logic and then add the UI. This time we won't go over the CSS specifically because we will use the exact same CSS code as we've been using for Vue.js. The rest of the things I will explain while developing, so let's jump right into the terminal to first create a new project by running npm create svelte latest, and we call it Svelte Chat App. We run this command. We need to install the package. We say yes, and now we want to select a skeleton project because we don't need any demo code for this, and this will even create a new Svelte Kit app. We want to use TypeScript. We want to add ESLint. We want to add Pinia. We don't want playwright testing, so we are fine with that. And this already marks it done. So we cd into the folder. We clear here, we say npm install, and we ls. So we see the project, it has been initialized, and now we run npm run dev. And since most of the ports are in use, we actually jumped to 5175. So we switch to the browser and we see welcome to SvelteKit working. So it looks like that worked. So we will close this again and we now open this folder in VS Code. Now, to give a very brief introduction, we have the usual files here. We have npm, Pinia, we have our package.json with the scripts. So everything as usual. And now the interesting files are in the source folder. We have a lib folder, which is not of interest for us. We could use this for creating libraries, but we're interested in the roots folder, which has the plus page.svelte, which is the page file that actually creates our component. So if we switch to the browser, we see this is the actual code that we are using here. So this is where our majority of UI code will actually go. But what Svelte offers is we can create a new file here. We can call this plus page.ts, and we can actually add logic that will be executed before this page is actually shown. So we can define the initialization logic right here and then access this to inside of our page later on. So let's first add logic here, and then we will cover the UI portion of the page.svelte file. Before we start the implementation, we need to quickly mention one thing. SvelteKit is capable of doing different types of rendering. We can do static site generation. So basically we build everything in a build step, which outputs the HTML and CSS and JavaScript code that's necessary, which is mainly used for pages like blogs that can be statically generated and then uploaded to a CDN, for example, which doesn't make sense for us here because we have a dynamic page that needs loading. Then the second option we have is server-side rendering. So everything is rendered on the server and only the parts that are rendered are then sent back to the client, which also doesn't really make sense here because we actually need to do client-side rendering because the user can log in and then we will dynamically load the data inside of the browser. For this to work, we first need to define here that we want to have server-side rendering set to false. I think it's quite nice that we can do this very easily inside of Svelte just using this one line of code here. So what we then do is we define the type of data that we want to load before our page is rendered. So we can define a type of load data. For this we need a few types from the Stream Chat SDK. We will have a user ID that we will feed into the page, as well as some channels and the Stream Chat client. From this, we can now say we want to have a load function, which is going to be asynchronous and return a promise with this type that we just defined. We can even say we want to import the types here of page load. I want to quickly mention that everything we're doing here is the exact same thing we're doing for the Vue implementation because it's very similar. We need to first initialize the SDK. We need to then connect the user and after that load the channels for this specific user. Things will look very similar, but there are slight differences for Svelte compared to Vue. So I will focus on explaining the things that are different and go over the things that we've already implemented a little bit more quickly. So we take the API key and the token from an environment file that we will create in a second and check if they are there. If not, we throw an error. Then we initialize the client and define the user ID. Then create a new function called connect user so that we extract this out a little bit. We set the username, create an object of type user, and then connect the user. We call this connect user function. And now we are running into the first difference compared to Vue, because what we now want to do is we want to load the channels. And we want to return these channels to the Svelte page. And we can do a really cool trick here, because what we can now do is we can define a function to load the channels, which we will implement in a second. And now we can return this function to the page. We can do this with this return statement. We first do the user ID that we defined above. We then do channels and we say await load channels. So what we can then do inside of the page is actually wait for the channels to load and then act accordingly. And we want to return the client as well. So let's first implement the load channels and then see how we can actually use this inside of our page.svelte file. This is again similar to the Vue implementation. We add a filter for messaging channels and the user ID. We add some options. We limit it to 10. We want to watch these channels because we want to see when there are changes or new messages appearing. And then we query for the channels with the filters. We sort them and add the options. We again create a new dictionary where the channel ID is the key and the channel itself is the value. And then for each of the queried channels that we received, we set this inside of the channel keys dictionary and then return this. This is all we need for the loading part. So let's quickly add the environment file. So we need the API key and the token here. So let's open up the Explorer, and in the root, let's create a new file, call it .env. And we need to add a API key as well as a token here. I already generated this for a user, so we can leave it as is. And with that, the Page.js implementation is already done. And now we need to take a look at how we can actually use this inside of the Svelte file. So let's first get rid of all the code we have here so that we have a blank slate to work with. So we add a script tag here, set the language to be TypeScript. And now we can access this load data that we created inside of the page.ts file. And now we can say we want to have this load data available as a data object. Now you might notice that we have left out two things inside of the page.ts file. The first thing is that we didn't have the active channel in there. The reason for that is that the active channel is a dynamic property that can change on click of the user. Inside of the page.ts file, we only add the data that we can load before the page actually renders. So we need to add the active channel now. For this, we import the channel type here, and then we say we have an active channel of type channel that we can now set. And whenever this will be set, the page will be recalculated and re-rendered. So let's do just that. We can check if the object.keys of the data.channels, so the channels that we are loading, if the length is bigger than 0, we can set the active channel to the first element here. The second major difference compared to the Vue application is that we haven't subscribed to any events happening, specifically new messages arriving. The reason for this is the same, because inside of the page.ts file we can load data, but we're not able to dynamically access any data inside of our page. So what we need to add here is whenever this component is mounted, we want to subscribe to new events happening, specifically new messages arriving. We can do this rather simply by importing the onMount function from Svelte, which is one of the lifecycle events here. And then inside of onMount, we access the client that we expose through the data object and say whenever a new message appears, we will do exactly the same thing as we've done for Vue. We extract the channel ID, and if it's present, we extract the channel from the data. We extract the messages from this channel, and then if these are present, we simply say inside of our data for the channels object, we set the messages to the updated messages. One thing we need to do manually here is that if the active channel is actually changing, we need to update this since this is not anymore dynamically bound to the object. So we need to manually update this. With this, we have all the script logic that we need, and we can start with the UI part. For this, we first add a main tag, and then I already mentioned that we can return from the page.ts a load channels promise that we await here. Now the way we can integrate this into our page is in the following way. So we can say we want to await the data.channels object. While we await this, the UI that is shown is going to be loading channels. And once it has arrived, so we can do a then block, and we can define the channels variable here. So we can have access to these channels and we know they are now loaded. So we can now create our regular UI for channels. And I think it's a very neat way to define the loading portion of the code here. and then react to the promise and the waiting state inside of the UI itself. So it's a very nice technique. I will go over the next parts a little bit quicker because again, it's the same thing as we've done for Vue, but let's go through it. So first we define a section for the channel list, and we say for each of the channels, and we go over the values here of the channels that we have received in the then clause. We go over them and we add a button. On click, we set the active channel to be the channel that we have inside of our for loop. We also add a conditional class of active channel preview if the active channel is the current channel. Then we show an image first, and then we show the name of the channel as well as the unread badge. We use the same code. If the channel.count unread is larger than 0, we show the unread badge, and if not, we don't show anything. And then we show the last message of the channel using this syntax here. Next, we show the channel section, and we first want to determine if there actually is an active channel. If that is the case, we start with the channel header. If not, so we can also use an else statement here, we simply display no active channel. Okay, so for the channel header, we first determine if there's an image. If yes, we show this image. Then we want to show the name of the channel, and we want to show how many members there are and how many of them are currently online. And for the message list, we need to add a little bit more logic. So we import the default generics and the format message response. We add a function to determine if this is a message from the current user. It's the same logic that we've added before. And then we go over each of the messages, same logic, also same Svelte code as we have done for the channels. We go over each of the messages and we create a message container. We give it the conditional class of own message container if it's a message sent by the current user. We add a message container here. And for this, we again need to determine the attachments. So if there are any images. So let's add the logic for this. So we first need to import the type attachment, and then we add the image URL for message function, same as we've done for Vue. So let's scroll down, and inside the message, we check if the attachment's length is larger than 0. If this is the case, we add a message image container. If there are multiple images, we also add the conditional class. And then for each of the images that we have, we show this specific image. And then we only show the text of the message. Again, we want to show the message signature, so the date specifically, as well as the username here. For this, we add another function here called format date. This is the exact same function as we had in the Vue code. So let's scroll down and say if this is not our own message, we want to show the username, and then we want to show the date when the message was last updated. Now the only thing remaining is the message composer, so we're going to be able to compose messages as well. For this, we need to have a message that we can type and that we can then send. So let's also add a send message function here, which is again the same as before. If the length of the message string is bigger than 0, we want to send this message in the active channel and set the message back to an empty string. So inside of the message composer, we can add an input, which we bind to the message, which is the syntax of bind : value. And we add a button, which we give the conditional class of active icon once the message length is bigger than 0. And on click, we want to send the message. As the content here, we add the SVG that we have used inside of the Vue app as well. So everything here is the same. And finally, we add some styling, which I will do just like that. Now, quite a bit of styling, but I can guarantee you it's the same code as for the Vue app, so I won't go over this. If you want to see this again, jump back to the Vue section. The only interesting thing here is that we can define a global style for the body to have a margin of 0, just like this. So we can save this now and take a look at the final result. So we jump to the browser and we already see it is working quite nicely. I think the font is different, but that's probably just the default setting of Svelte. We see the list of channels here. We see the unread indicator. We can see the channel header here and all the messages. We see the name here. Interestingly, this user has an undefined name. Cool. But we see the date, we see the message, we see the border radius, so all the CSS that we've applied here. And we even see that our own messages are aligned towards the end here. So everything seems to work perfectly. So let's test this by typing a message here. We say hello from Svelte, and we can send this here and this appears. Again, we don't have the scrolling behavior, but that is fine. But our app works just like we intended. Now, the last thing I want to do here is compare the Svelte to the Vue implementation. So I've started the Vue implementation on localhost 5174. You see this is a different user, right? So we can scroll down. We can see that Franco wrote hello from Svelte. So let's write back hello from Vue. We sent this and we can see this message appeared. And if we scroll down here, it also appeared inside of our Svelte app by Rogelio. So as we can see, we can now chat between these. We have done the UI completely ourselves. So I think it's quite remarkable that we can achieve a very similar look here. And a lot of the logic can be shared and is the same. There's just some nuances between the frameworks. For example, the mounting of the component and where to put the initialization code. With this, we have seen now two frameworks where we had an SDK available, combined with UI components available as well, with React and Angular. And on the other hand, we had Vue and Svelte, where we had the low-level client available, but had to implement all the UI ourselves. For the last framework, we will do something a little bit different. So let's do this now. The last framework we're going to be using is a new up and rising framework that is lesser known, but is gaining popularity quite a bit, and it's called Next.js. Now, Next.js is using React under the hood, so a lot of the things for the implementation will be similar to the React example that we had. And this is why we will add a new feature on top here, and that is dynamic token generation. We will not use a hard-coded JWT, but we will show you how to use server actions in Next.js to generate a token dynamically. So without further ado, let's jump into the console to create a new Next.js app. We use the npx command here to create a new project. We call it Next.js chat app. We want to use TypeScript and ESLint. We want to use Tailwind, which we don't really need, but that's fine. We don't want to use the source directory, but the app router. We don't want to customize the default import alias. And with that, our project will be initialized. Once that's done, we can clear this and we can cd into the folder. And first of all, install the dependencies for Stream Chat and Stream Chat React again. This is done, so we can now open up VS Code and we see our project being initialized here. The first thing we're going to be doing is we're creating a separate component now. So let's create a components folder, and inside we add a new file. We call it app.tsx. What we're going to be doing is we are filling this up with the necessary chat logic. And then we want to, as I mentioned, dynamically create the token. So we will add a server action to the root page here to dynamically create a token for the current user. So let's get started with implementing the app.tsx file. The first thing we need to ensure is that our component is running on the client. So we add the use client hook. The second thing we want to make sure is that we won't forget to import the necessary CSS for the stream chat module. So let's do the import next, just so to make sure we don't forget it. Now we want to create a component. So let's add the skeleton for this. We export the app component here. We will have parameters, and let's think about the ones that we need. We want to initialize our client, so we need an API key for this. And I mentioned that we want to dynamically create tokens. So let's also add a parameter here, which is called create token, which will take in a user ID, which is a string, and it will return an string as a promise. Then we also need the user ID as well as the user name here. So we won't extract this here, but we will get this as parameters. We want to use all of them, so let's extract them here. And let's start with the implementation. Now the first thing we want to do is use this create token function to actually create a token whenever necessary. So we need to wrap this in a use callback hook that we import from React. And then we simply call this create token function with the user ID that we're getting handed down and return the result. Now, how does this work? We will get to that in a second, because next we import the use create chat client. And this is actually where we will use this token provider function. And the way this works is that we have the use create chat client, we add the API key, and what we've done so far in the other examples is simply provide a token, so a hard-coded string, to authorize the user as a JWT. But what we will do now is we will use a token provider, which works in the following way. On first initialization, it is called and a token is generated. This token has a lifetime, so it's valid for a certain amount of time. And once it gets invalid, the token provider will be called again to issue a new token. So with this simple mechanism, we make sure that the user stays authenticated and new JWTs are automatically issued. Then we also need to add the user data. We have the user name and the user ID. We add an image, and with that, the client should be initialized. If not, we return the following text that it's currently set up. Otherwise, we return a chat object that we need to import from the stream chat React package. And we can now use this chat object and inject the client that we just created. Now we also want to show the channels. So let's add the parameters for this. We have a sort function. We need to import the types here from the packages. And also we have filters. So we only want messaging channels, and the members of the channel should include the current user. We have other options such as limiting the channels to 10 for now. And with that, we can import the channel list here and inject this here. So we already have a channel list available. And then we also want to have all the other UI elements such as the channel header, the message input and everything. So we import this and we add the channel here, window to hold all the other components, the channel header, the message list, and the message input. We know this, we've done this for React, Angular, and we've done the custom implementation for Vue and Svelte. And finally, the thread here. And with that, the implementation for our app.tsx file is already done. So we can save this. And now we jump to the page.tsx, where we actually want to call this app component. And so we get rid of all the UI code here, which is quite a bit. And what we want to return here is the app. But for this, we need to prepare a few more things. First, let's add the server action here. And we can do this by defining an async function called create token, we get the user ID as a parameter and we return a promise that is a string. Now we need to make sure that this runs on the server because we will be using the secret of our application here, which we don't want to expose on the client. So we need to make sure that this runs on the server. So we use the use server directive here, which is a very handy way because we can define this on function level, which is very convenient for us. Then we extract the API key as well as the secret from the environment here. We will add the environment file in a second. We will extract these. If any of them is not there, we will throw an error. If they are there, we will create a new stream chat object on the server, so a server client here, using the API key and the secret. We need to import this from stream chat. And then we simply return the result of the call to create token using the user ID that we get as a parameter here. Now, as a reminder, this function will get called repeatedly every time the token that we create is invalid and the need to issue a new token arises. So the rest of the function is pretty straightforward. We will extract the API key as well. We will define the user ID. We will hard code this here, but we could also think about handing this towards this route with a query parameter or something. We will also define the username. And then we will say if the API key is not there, because we're getting this from the environment, we will show an error. Otherwise, we will use our app component that we need to import, and we will use this and hand in the API key, the create token function, the user ID, and the user name. We can save this. And now there's two more things we need to do. The first one is to create an environment file. So let's do this now. We say new file, call it .env, and we need two parameters here. And these are first the API key, and second, the stream secret. So this is the secret for our function that we only want to expose on the server. Again, we save this. And now we need to do one more CSS thing. And we can use the globals.css file for this. We can get rid of everything here because this is just the template code that comes with the default Next.js project. And instead, we will now add the following code, which is this. And this is just regular setup code for stream chat. We define the HTML, the body, and the root to be height of 100%. And then we set the body to a margin of 0 and a display of flex. We define the width of the channel list, the channel, as well as the thread. With this, we can now check if this is actually working and if our token gets initialized correctly and the rest of the app is shown correctly as well. So from here, we can jump into the browser. We can open up the localhost on port 3000. We see that first we get the initialization message and then everything is loaded. Obviously the token generation worked. We see the different channels here. We can switch between those and we can even type. We can say hello from Next.js and hit send, and everything works just as we expected. So this marks the end of the last implementation of our fifth framework, which was Next.js. We even add a little specialty with the dynamic token generation using the server action in Next.js. Awesome job finishing this, and let's jump to the conclusion. In this project, we have achieved quite a lot. We have built a chat app in 5 different frameworks. We've started off with React, where we had a library available to build not only the client side, but also the UI components. And then we went to Angular, where we had the same foundation. So we could use the UI library to quickly build up a chat implementation. Then we switched to Vue and Svelte, where we had to do everything from scratch, only being assisted by the Stream Chat client, which was able to dynamically load channels as well as assist us in sending messages. Finally, we added an implementation for Next.js, where we even added dynamic token generation, getting rid of the need to create our own server, but making use of React server actions that were running in the Next.js application. As a reminder, this project can also be found on GitHub, and you'll find the link for that in the description of this video. We hope you enjoyed the video. If you did, please consider liking this video and subscribing to the channel. This helps us immensely. If you want to see other frameworks being covered or other applications being built, then please feel free to comment or reach out to us. We're always happy to play around with other frameworks as well. Thanks for watching and have a great day. Bye.